We're taking a big turn in this new unit, transformations, right? Big turn. You know, sine, cosine, tangent, triangles. Big difference here, big difference. And I think some of you guys have some history of it back in the middle school, maybe 8th grade. But I'm not, that doesn't matter to me. I'm still going to take this pretty slow today. So I apologize if it's too slow for some of it. I do want to go over some vocabulary that we're going to be using first, this entire unit. When I take a figure, so for instance here, let me just bring up a new chart. When I take a figure, so take my triangle, and maybe I slide it up, down, left, or right. After I'm done, if the segment length and the angle measures are the same, all right, of these two figures, they're the same side length and same angle measure, we're going to start referring to that as what's called a rigid motion in this first blank right here. Rigid motion. So anytime I do something to a figure and the length of the sides and the angle measurements don't change, we're going to say, hey, you performed a rigid motion. Okay, you performed a rigid motion. Now, there is one transformation we're going to talk about that the side lengths don't change. Anybody remember what that's called from your middle school days, maybe? Here you go. What did I just do there? Now my side length, that's not a rigid motion because my side lengths definitely got bigger. Dilation. That's called, remember, dilation? My side lengths changed, but guess what didn't change, though? My angle measures, all right? So next one in there, when I perform a dilation, that preserves angle measure, but not lengths. All right, so once again, a quick review here because these are important terms. Anytime I do something to a figure, maybe I could turn it too and move it. As long as their length, side lengths and angle measurements stay the same, we say you did a rigid motion. Okay, we did a rigid motion. Last thing I need to talk about. We actually have a name for the starting figure and for the ending figure. Okay, the figure we start with, we're going to refer to that as the pre-image. The pre-image. So that's the figure we are always given, the pre-image. We're going to do something to it. Move it, turn it, flip it, blow it up, shrink it. The ending figure, we're going to just call the image. All right, the ending figure, we're going to call the image. So if you ever hear me say pre-image, that's what we start with. And then I'll ask you, okay, what's the image? What do we end up with? All good? All right, let's dive deep into this thing then. State whether a transformation if this appears to be a rigid motion or not. So remember, rigid motion, the side lengths and the angle measurements do not change. Does that look like it in number 1? As I go from the triangle on the left to the triangle on the right. Side lengths change? Yeah, they did. So this cannot be a rigid motion. This is not a rigid motion. So no, side lengths are different. It's referred to as a rigid motion when everything stays the same. What do you think about 2?
Yeah.
Look like a rigid motion happened? Yeah. So yes. And our reason will be side length and what else stayed the same? Side length's not good enough. Side length and angle measure stayed the same. Okay. Side length and angle measure remain the same. All right, we're going to talk about different types of rigid motions. Today, reflections. Think about it real quick before I get into it. Reflection. If I reflect, flip an object, does it change the side length? Does it change the angle measure? So that's why a reflection is a type of rigid motion. So that's our focus today. How do I reflect things? First thing, Symbol for reflection. Reflection starts with the letter R, so we have lowercase r. Lowercase r. Lowercase r, reflection's happening. You guys know what I mean when I say subscript? Subscript. Anybody know where a subscript's located? Cal?
Like under.
Under, the bottom type. You'll see a subscript here. That'll be whatever line we're going to reflect over. So I'm going to put line of reflection here. And I'll show you, give you an example of what I mean right now. So here's an example of what you'll see. Lowercase r. And then some type of subscript. So in notation, what am I telling you to do? What's lowercase r mean again? So I want a reflection over what line? What's the subscript say? The y-axis. All right, so that is how we're going to write it and read it. So I want you to take whatever I have for you, reflect it over the y-axis. All right, you ready to actually reflect now? I'm going to take this super slow. Sorry if it's too slow. So let's start in the top left. Everyone see point A, 2, -1. Put it on your graph right now, please. Put 2, -1 on your graph right now. 2, -1, call it point A. Again, taking this slower. Look what's on the arrow. This tells you what to do to the point. Lowercase r for, again, reflection. What's the subscript say? Subscript says do it over where? X-axis. All right, so everyone locate the X-axis right now. I'm going to teach you how to reflect if you don't know already. So everyone, yes, this is the X-axis right here. How many units away is A from the X-axis? 1. Everyone agrees. 1? So that means I go 1 unit away in the other direction. The distance stays the same. So I'm 1 unit away from the X-axis. I go 1 unit away on the other side, and there's my new point. But I can't call it point A anymore. I'm not going to call it another letter either. Anybody know how I represent the reflected point? Via, do you know?
You put like some sort of apostrophe next to it.
All right, yep, it's called a prime. So everyone, now I label this A prime, which means point A was reflected or transformed. So go back up here. A becomes A prime, and I'm going to start calling on people. What's the coordinate of A prime now? What's the coordinate of A prime? Oh, sorry, let me do this over again. 24. Let's do this. 15. What's the coordinate of A prime right now? 2, 1. So 2, -1 became 2, +1 when I reflected over the X-axis. Count the distance and then match it on the other side. Next, let's go bottom left. Take 2, -1 now, so go back to A. Take 2, -1, but now where do I want you to reflect it? Over the y-axis. So everyone count. Count your distance. How far is A away from the y-axis? 2. So everyone go 2 more units away. Call this, no, it's still A prime. It's still A prime because we're doing it from A. So somebody now tell me the coordinate of A prime after I reflect it over the y-axis. 24, not here. Suspense. 23. We don't? We went, what are we on? 18? 19? Does everyone have a number, first of all? Who has 18? 19? There you go, Scott, 19. Welcome to your new number. Thanks for the reminder, too, everyone. 16. What's my new coordinate? -2. -1. Good. Everyone's all right. Count the distance, because now I'm going to change it on you now. That's nice and easy when it's the axes. Go to the bottom right, please. Bottom right, everyone. Everyone see the subscript now. Reflect over the line. Y equals 2. We got to know what that looks like. We got to know what that looks like. Y equals Y just by itself. I'll let you guys shine. Anybody know? Don't tell me straight. They're all straight. Y equals by itself. Anybody remember what type of line that is? Horizontal. So everyone ready? Y by itself is a horizontal line going through 2. Right there. That's that line I want you to reflect over. All right, that's the line Y equals 2. All right, so everyone go back to A, 2, -1. Count. How many units away is it? How many units away is A from Y equals 2? 3, so everyone go 3 on the other side. 1, 2, 3. 1, 2, here it is. 3. And now you just have to name the point. What is that point? 17, what's that point?
Like the coordinates?
Yeah, coordinates, yep.
2, 5.
2, 5. All right. So all I do is I find the line I'm reflecting over, count the distance, go that same amount on the other side. Any issues? Because now this is a new type, top right. Everyone go to the top right. 2, -1, reflecting it over the line Y equals X. Y equals X. All right, this is the first time I'm going to have you guys reflect over a line that is in vertical or horizontal. Let me get this out of the way. Do not graph this. Do not graph this. I just want to show you on my version up here. Take a look. This is the line Y equals X right here. I want you to take A and flip it over that line. And the way I'm going to have you do it, I'm just going to have you remember the rule. Okay, you can't count. There's no counting. You can only count when it's horizontal and vertical. Okay, when it's diagonal, I can't count. So I'm just going to give you a rule right now. When you reflect over this line, Y equals X, switch the coordinates. Flip them. That's it. Just flip the coordinates. That's all that happens. So 2, -1 becomes -1, +2. So I need you to remember that rule. When you flip over the line Y equals X, swap the coordinates, flip them, whatever word you have. Switch them, flip them, swap them. Because now, hey, take a look. -1, +2. You see how I flipped it over? Looks flipped over, doesn't it? From A to A prime now. All right, I'm going to let you go on your own now. It's time for you guys to do one on your own. So take a look, graph triangle ABC for me right now. 1, 6, 4, 3, 2, 1, and I need everyone to reflect it over the y-axis. And put A prime, put B prime, put C prime. All right, so everyone graph triangle ABC first. I want to walk around and see you do this. And go ahead. Y-axis, everybody. Y-axis. Y-axis. Not the X, the Y. So count your distance, match it. Make sure you put a prime with it, please. Put a prime with it. A prime, B prime, C prime. Y-axis. Y-axis. Connect them, make them look like triangles. Make them look like triangles, please. Connect them. What's going on?
Well, no, hold on.
I don't know what's going on there, but all right, look good over the y-axis. We're comfortable there. We can reflect over basic lines before I get too hardcore on you. Any questions? I'm moving on. All right. All right, let's do this one together. So everyone take point X 0, 5. Throw it on your graph. 0, 5. 0, 5. Hopefully we know what that is. I always worry. Make sure we're putting it on the y-axis. So that's point X. And everyone sees what they're asking us to do with it, right? Reflect it through the line X equals 2. We just went over a problem about 5 minutes ago that was Y equals 2. What do you think X equals 2 is going to look like? X equals 2. What type of line are we working with? Vertical line. Yes, a vertical line going through 2. Right there. Vertical line going through 2. X equals a number is always vertical. Y is horizontal. All right, go ahead, flip it over. And I'm going to ask somebody for the coordinate here in a second. Count the number of units to the line and go that many on the opposite side. And what do I call this point? X prime. Can't call it X. All right, so what coordinate you got for me? 14?
3, 5.
How many units away was X from the line?
I got 4, 5.
4, 5. So everybody, X prime 4, 5. Read carefully. Read carefully the next part. What am I going to reflect? What's it asking me to reflect? X prime. I don't go back to X. I stay at 4, 5 now. So take X prime and reflect it through the line Y equals -3, which will be what type of line? Horizontal. Good. We're picking it up. Y equals -3. And yes, I did this on purpose. You're going to run out of room. Use your head. Use some math. You can do this. Come on. We did this on purpose for you to run out of room on your graph. You got it. You can still figure out where it's going to land. Come on, dig deep. Count the distance from Y equals -3, going the other way. Do I have anybody doing this? Well, look at me, Mr. Carlino. I'm making my graph longer. Have some self-respect. Okay, before I ask for the answer, notation. You just reflected the prime. So now this point's going to be referred to as X, not prime again, double prime. All right, when you reflect the prime one, you now call it double prime. If you went back to the original, you could still keep it prime. All right, so what is the coordinate of X double prime? Come on now, come on. I know you ran out of room, but you're good enough. You're good enough. 7.
Would it be no, it would be 4, -11.
There we go. Again, guys, you went what? 8 units here? So go 8 units again, but -3, 8 units down gives you -11. Yep. Good job, everyone. Good job. Any questions? All right, next up. Can everyone graph line segment FG for me? 3, 0, and 4, 3. 3, 0, 4, 3. And underneath it says now, and I put this in symbolic form, rotate it, Jesus. Reflect it through what line?
Yeah.
Y equals X. I just gave you a rule for that. Go back and look if you need to. Y equals X. And then tell me what F prime and G prime are going to look like. All right, what are the coordinates of F prime and G prime? It's just one rule I just gave you when I reflect over that line, Y equals X. So here we go. 15. What's F prime going to look like?
0, 3.
Good. I just flipped the coordinate 0, 3. And G prime will be 7.
4, 3.
That's G, 4, 3. G is 4, 3.
Oh, 3, 4.
3, 4. There we go. So let's graph it. 0, 3. F prime. G prime. 3, 4. And just so you guys believe me here, why that rule works, again, here's the line we just reflected over. Right there. So it looks like I flipped it right over. All right. Okay. Now take FG and, ooh, a new line, huh? New line, Y equals -X. Take a quick peek. Here's the line Y equals -X. This is the second and last rule I'm going to give you. Y equals X, you flip them, you swap them, switch them. Y equals -X, flip them, and change their sign. Y equals -X, swap them, change the sign. All right, and that's the second and last rule I'll ever give you. So what's F prime going to look like? Because I got to do it to FG. Flip them, change their sign. Zach?
0,
What is it?
0.
0, -3. Flip them, change their sign. And how about G prime now? 4, 3 becomes, flip it, change the sign. 4, 3 becomes 2. Good. -3, -4. So graph that. 0, 3. -3, -4. Nope, sorry, I graphed that wrong. There we go. There it is. Last time, Y equals X, you flip them. Y equals -X, flip them, and change their sign. And that'll be it. Those are the only 2 rules I'll give you. All right, before we get to the compass work, you find the line of reflection now. So here's triangle ABC. Here's triangle A prime, B prime, C prime. Graph both of them. Look at your graph and say, all right, where would the line I reflect over be? And give me the name of it. So draw triangle ABC and A prime, B prime, C prime. Look at your graph. Figure out where the line would be that you would reflect over. And then tell me the name of that line. You got this. So see if you can draw the line of reflection on your graph, and then can you give me the equation of it? So everyone, hopefully, nope, that's not professional. Hopefully you guys found drawing that line on your graph right there. And there's the line it must have reflected over. Tougher part, what's the name of it? Right? What's the name of that line? We talked, it's vertical, so you got to know how it starts. All right, what's the equation of that line? 17, got anything for me?
X equals 3.
There you go. It's vertical, so it's got to be x equals, and it's going through 3. Good work. All right, last thing I want to do to you today. I still want to find the line of reflection, but I'm not on a graph. All right, I still want to find the line of reflection, but not on a graph. Everyone see, I'm going to make you use your vocab now, so if you have to go look back at the beginning. Here's the figure I start with. What do I don't want to say that anymore. What is this figure called, the figure I start with? Look back if you need to. What's it called? Pre-image. And this is because I see the primes on it, this must be, what do I call the figure I end with? Image. So I got pre-image and I got image. Where on your paper is the line I must have reflected all of them over? All right. Grab your compass. All right. Well, not yet anyway. Have it right next to you. Here's how we're going to do it. First, whatever straight edge you got in front of you, calculator side, whatever, match up a pre-image point with an image point. I don't care which one it is. So take a pre-image point and match it up with its image point. So A prime, B prime, whatever. Match it up for me, everyone. Make a line segment. So match up a pre-image point with an image point right now. What do I want to do here? B prime, I guess, sure. And now take your compass, because we're going to review a construction you did probably with me way back in September. And we're going to do the perpendicular bisector of that segment. The fish, I don't know if anybody remembers me calling it the fish. So let's do step by step again. Take your compass, put it on one end point, open your compass up more than half the distance of your segment. Ooh, it's been a while. And make a decent size arc, like almost a half circle type. Leave it the same opening and go to the other end point of your segment. So you just did that half circle. Go to the other end point of your segment and do another half circle. So those two should intersect in two spots. 1, 2. And then whenever you're ready, grab your straight edge, draw in your line of reflection. That's the line of reflection right there, the perpendicular bisector. And just make sure you guys make a little note of it. All right, make a little note. That's the line of reflection. So that's all it is. It's the perpendicular bisector. And then go ahead and I'll let you try it on M. Share your compasses around your group. I appreciate it so everyone gets a handle on this. I'll do M up here for me, and then I'll come around and take a look at yours. Make sure it's a pre-image with its image.
I have to leave at 10:45.
We'll be done. As you guys are finishing, please listen to the rule in this unit that you need to follow. Anytime you're doing the homework and the textbook homework says to graph, you graph. It's not optional. Okay, it is not optional out of the textbook. Anytime the textbook homework says to graph this figure or whatever, you graph. So to make sure there's no excuses, at the back of your packet, you have a slew of graphs on the back. Okay, for you to use if you don't have your own graph paper. In addition, if you don't want to use that, I have slices of graph paper over near the door over there. If you'd like just a slice of whole graph paper instead. All right, but if it says the graph, it's not optional. All good? Okay, you guys can go ahead and start things up here. We've got plenty of time still. There are a couple constructions on page 5 I need you to do, and then the rest is out of the textbook. Graph means to graph it. Answers up on Classroom like usual.